Okay, now I will talk about deep learning neural networks. First, what are they? Deep learning networks are more complex than normal neural networks. They have many layers, and each layer changes input data step by step. Until we get the final output, you can think of it like a factory line, raw materials going, and after many steps, a finished product come out. Second, what are they used for? Deep learning is used mainly for finding patterns in data, especially when the data is not labeled. This is called unsupervised learning. For example, the system can look at thousands of pictures and automatically group them, even if no one tells it what the picture means. Finally, why are they important? Some people believe deep learning is the close technology we have to use ground vision with AI, which means machines that can learn and think almost like humans. So, in short, deep learning networks are powerful, complex, and a big step toward the dream of true artificial intelligence.
Hello guys, and my topic is talking about the deep learning network. What is this? This is very interesting. Why I want to talk about it? Because just like the human, we all have a lot of innovation and invention is made from the natural. What means that like we have the airplane, which is imitate the bird. And for this system, for the deep learning, which is imitates the human brain, which means it is the like the to stimulate the how the brain working. How I want to say that because deep learning network is have the 3 layer, right? And we have the neural link, we have the neural, and we have the word which is simplexes, and this is very different words. So I change it to be the touching, which means you have a lot of the neutral in your brain, and when your neutral touching one time, that have something happened. Like if you see a girl and which is very beautiful and you want to fall in love with her, and sometimes your neutral will touching. So when you're that touching and you will think that is beautiful. So that is how the neural link is working. So this is a deep learning network. And for second, I want to stimulate the, can I use the pen? All right, thank you. And so if I write a word or write something to stimulate it, and when you first see it, you will think, what is this? You don't know what it is, right? But you will to observation it, but observe it, and you will see this line and the second line, different lines like that. And I will tell you what's this. This is Cushing Laco, and you will want to understand what is Cushing Laco, right? But you know this is the word with the Cushing Laco. So this is your first deep learning network. So human is like a big machine, just maybe from your different experience and something like that. So when you have a lot of knowledge, so you are different like it. So I will tell you this is the full. Okay, you have the 2 layer deep learning network. So you will know this is food, and which is the, I tell you the, this is some like the food and can also use for the pharmacy. It is medicine and can cure your cancer maybe. So that is all your brain to identify this. And the artificial deep learning network is same like that. The first we'll see what is line, and when the system low is a line and low is that the circle or the square, and there is a triangle have a different, and to analyze the different picture, and it will load this is the food and will be load food and search in the Google and load medicine like that. So which is the like the deep learning network, but the learning network have a huge number of the data that's different with our brain. Okay, that's all. Thank you.
Okay, let's see. Okay, let's see this slide. This slide is talk about natural networks. Okay, first data dependency on the slide. Natural network needs massive database to learn, just like you need lots of examples to master a skill. No big data, just learning falls apart. Okay, the next is shaky partners. The partners they find might be meaningless, like seeing shapes in clouds, or vanish fast, not reliable for big decisions. Then is black box mystery from the slide. We often cannot explain how they decide if a healthcare AI suggests a treatment. We need to know why, but it's hidden and ethical wild no more sense as our side knows. Left alone, they might recommend unfair or illegal things. So I think this host needs human oversight to work well.
Today I will talk about the genetic algorithms. Genetic algorithms help us find the best answer when there are many choices. They look like evolution in nature, where you form answers by changing and mixing parts. It uses ideas like inheritance, mutation, and selection. They are useful for problems like service cost, include schedules for vending machines. These problems have many variables. The good thing is that genetic algorithms can test many answers fast. Okay, that's it.
I like to talk about the components of a genetic algorithm. Here you can see a figure that illustrates how it works. On the left, we have what's called a population of chromosomes. Each chromosome is basically a strand of 0 size and 1 size. And you can think of them like potential solution to a problem. Now the next step is decoding. Each chromosome is translated into central characteristics. For example, one chromosome might represent something that is long, wide, light, while another might represent short, narrow, and heavy. After decoding, we move on to evaluation. This is where we assign the fitness source to each chromosome. The fitness tells us how good the solution is. For instance, in this example, the fitness value range from 36 to 74. The higher the fitness, the better the solution. So overall, the genetic algorithm works by generating a population of solutions, decoding them, evaluate their fitness, and then use the information to evolve better solution over time. That's the basic idea shown in this figure, a very powerful way of solving complex problems by mimicking natural selection.
I will talk about natural language processing, or NLP. NLP is software that can understand human language, like our process or text. For example, when we type in group search, NLP help the computer understand us. It is usually based on machine learning and deep learning. That means the computer learns from a lot of data to improve. We can see NLP in many processes. Google search, blocking just emails, checking revenues to see happy or unhappy words, and sort customer help.
Today we are talking about computer vision systems, emulator human vision, synthesize tool video and extra information from reading what images. For example, Facebook's deepfake can identify a friend in photo cost systems and the entire autonomous vehicle can recognize things, read, marker, people, animal, and other vehicle with good reliabilities.
Quite difficult, but they are touching it. Like the computer have the